Welcome to this new series of videos on Linux related stuff. Today's presentation will focus on open source operating systems and is meant for people who wish to compile and install software direct from original authors rather than relying solely on the software and versions provided by their operating system. Needless to say, a certain amount of background is assumed on the part of the user. Specifically, you should have available a C compiler together with tools like MD5 sum, make, and patch program. The C and C++ compiler is the workhorse of all Linux systems. 2. Experience working with command line is required together with standard Unix tools like wget or curl and standard Unix commands like cat, copy cp, make directory, move, ls, find, tar, gzip, etc. I will assume that your operating system has a bash shell. The compilation and installation cycle is shown in the next slide. As stated earlier, you must first check that all the prerequisites are satisfied. The next step is to obtain the source code and doing an file integrity check on the downloaded file. The source code is generally a compressed tarball, as they say, which has to be exploded to extract all the files in the archive. This is done via the tar application. Once the archive has been exploded, you must first read, reread either the readme or the install file. These files contain important and useful information. Once the instructions are clear, you have to run the make program, which will do some housekeeping and finally invoke the compiler to produce the machine code. If all goes well, the make install has to be executed, which will install the final executable machine code in proper directories as laid out in the path environment variable, and it will also install the documentation associated with the particular program. Let me spend a minute on the advantages and disadvantages of canned distributions. The biggest advantage is that the distributions help find, download, and compile and make the binaries for you. In addition, A package manager maintains a database of all the softwares installed. The maintainers of the distribution take care of security updates in the form of patches. So it's a quick installation, one stop shopping. The disadvantage is that the latest version is often not available. The canned distributions, they carry a lot of baggage. They have to cater to many platforms and worry about legacy features. In addition, the package manager imposes a constraint. You cannot just install a package on your own. If something goes wrong, then it will mess up your operating system. Downloading source code is a simple one click process. You go to the website, either there will be a download button, you click on it, or there will be a link. You right click and select Save As. Once you have downloaded the source code, you must also download what is called the MD5 sum file. It may be a single file or it may contain a list of files with many MD5 sums. The first thing you should do is check the integrity of the downloaded file. And this is done by running a program called MD5 sum from the command line. The syntax is very simple. It is MD5 sum with the name of the file which you want to check. The program will spit out a series of hexadecimal digits which you must check with what was downloaded from the website. In case there is a list of files, then the syntax is MD5 sum dash C and the name of the MD5 sums file. One helpful tip: make sure you download via the secure HTTPS protocol. What is an archive? Archives is a place where public records or other historical documents are kept. Any extensive record or collection of data may be called an archive. In the computer world, an archive is a long-term storage device such as a disk or magnetic tape or a computer directory or folder that contains copies of files for backup for future reference. In the modern world, an archive is a computer file containing one or more compressed files. TAR is a Unix utility. It's short for tape archive because historically data was backed up on tapes. It is the conventional format for file packaging but not compression in Unix-like environments. A tar archive consists of a series of file objects, hence the popular term tarball, referencing how a tarball collects objects of all kinds that stick to its surface. The format of a tar file is that it contains a header for each file, and it is indexed by things like file name, the owner's name, the file size, the checksum, and several other properties, so that the file can be extracted later on again. Usually it is compressed after creation. One of the best softwares for extracting and compressing files in the Windows environment as well as Linux is what is called 7-zip. You must have it on your system. Linux provides other equivalent softwares like gzip. Files compressed with gzip have endings in .tar.gz or .tgz. Then there is bzip2 with suffix .tar.bz2 and occasionally xz, suffix .tar.xz. As far as we are concerned, the syntax for using the tar program is tar with an option of extract and the file name. This can be shortened to tar -xf file name, or even the dash can be omitted. It's simply tar xf file name. So this program will uncompress the file as well as extract all the components contained in the file. The same step can be performed in two steps by first using the gzip program to uncompress the file and piping it to the tar program. Where are tar files exploded? Well, when you run the tar program, it will create a single subdirectory within the current directory. So let us say we have downloaded a file which we place in a directory called sources. And when we run this tar program to extract the tarball, it will create a subdirectory in the folder sources. And all the packed files will be extracted into that subdirectory. For example, the Linux kernel, the tarball is called linux-5.10.17.tar.xz, which is one of the latest versions, version 5.10.17. So if we explode this file, the subdirectory which will be created will be called linux-5.10.17, and all the files in this Linux tarball will be extracted in this directory. Sometimes if the packager of the tarball has not followed proper protocols, the tar file will expand its contents directly into the current directory, and that may cause a mess. In order to avoid this mess, it is better to check the contents of the tar file. This is done by using the T option. Tar minus TF, the tarball file name, will simply list the contents of the tarball. That way you can see whether you want to extract in the present directory or create a new directory. After you have extracted the files from the tarball, the first thing you must do is read the readme or the install file. These files give important information about how to compile, install, and configure the rest of the source code in the downloaded archive. You must pay attention to the dependencies. The software you are trying to install may depend on other softwares. So you must first install those. Moreover, any program you download will require some local header files and library files and or helper tools to build or to run. If you don't get the prerequisites right, then the application may not compile, or even if it compiles, it may not run, or it may get built without certain features that you want. Another important piece of information in these files is the set of parameters that can be passed to the build process. Let me now talk about what is called the patch file. Well, a patch is a patch. It's like a patch on a gene. These days, there is a fashion of people tearing the gene and then putting a patch. So sometimes the downloaded software is known not to work in a particular environment. Some good person has already figured out how to tweak it to resolve the problem. He or she may publish the tweak as a sed or awk command, a shell script, or a patch file. The sed tool applies a regular expression to each line and replaces matching text with something else. Awk is capable of performing more complex transformations of text files. A patch file is created by using the what is called diff tool. Now I come to the most interesting part of the build process. Building a software involves two major steps. The most important one is the compilation. Compilation means converting the source code written in a higher level language like C, for example, to machine instructions. That is, in a binary form which a machine understands, the processor understands. The second step is installing the executables and related files into proper directories that are listed in the path variable for all users so that they can execute those files. Installing modules for interpreted languages is slightly different. For example, for Python or Perl, you just have to place the files where the interpreter can find them rather than in the environment path variable directly. The most widespread tool used to manage the compilation and installation of source code is a program called Make. Make is an application which takes a configuration file called a makefile that contains a list of rules. These rules are of the form: there is a target file, there is a source file, and some action. So the rule says when the target file is older than the source file, then some action should be taken. We'll see an example of this soon. The target file is the end product or some intermediate stage. The source file is the handwritten source code or some intermediate artifact. The action is usually the invocation of a compiler, a linker, or something similar which recreates the target file. Many software packages come with a shell script called configure and a template makefile named makefile.in. The configure script takes a list of configuration options on the command line and converts the template makefile into a real makefile customized for the local computer and the installer's website. So let me illustrate the configure and the make process. You have downloaded the source file and let's say you have placed it in a directory called sources. We change to the directory sources and issue the command tar xf and the name of the file which was downloaded. In a span of few moments, the whole tarball will be extracted into a subdirectory as I had illustrated earlier. So the next command we give is cd to that directory which was created in the previous step. As I said, we must read the readme or install files, and there is a very useful utility in Linux or Unix called the program less. So if you issue the command less readme or less install, you will see on the screen one page at a time the contents of these files. Once you have finished reading a page, you can press the space bar to go to the next page, or if you are satisfied, you press the Q key for quit. So after you have ensured that all the prerequisites are met, we will issue the command /configure with some options which will be mentioned in the readme or install files. So here, what is the meaning of dot? Dot means the current directory, which in our case is sources. Dot slash means look in the current directory for the file named configure. So that's a script which will be run. If everything goes well, the next step is we simply issue the command make. So here all the interesting stuff takes place. The compiler, linker, etc. are run, and you will see a lot of things being thrown onto the screen and they fly past you. Don't worry about them. What is important is look for errors. If there are no errors, be happy your program has compiled. And the final step is you do sudo make install. A sudo is a command to get the privilege of the system administrator or the super user as they call it. Because on a general system, there are certain directories which should not be touched by the normal user. Only the system administrator should be able to use them. So most software will install certain parts of the executable in the important directories slash bin etc. And to do that you need the permission of the system administrator. So this completes the build process. Here are some useful notes. Configure is usually invoked as dot slash configure to avoid two possible problems. Users do not have a dot in their environment variable path. In particular, the root user does not have this for security reasons. Next, some users don't have a dot as the first entry in their path, in which case there is a possibility that the wrong configuration script might get run. Remember that the operating system searches the path variable from top to bottom, and the first place where it finds the necessary information, it picks it up from there. In general, it is best to perform all steps except make install as a normal system user, not root. This avoids mistake and possibly some attacks. Moreover, installing software into the global /bin or /user directories usually requires administration privileges. Finally, some projects provide a makefile but no configure script. In this case, the configuration step above can be omitted. Either the application is simple enough that it does not need it, or the software developers have built more logic into the handwritten makefile. More notes. For most software, the configure and make commands can be run in the same directory as the source code. The result is that new files generated during compilation get mixed together with the originals, which is somewhat messy. But the make clean command, which I will talk about later, can be used to tidy up things later on. However, for some software, it is necessary and recommended to create a temporary directory, change the current working directory to that directory, and then perform the build steps there. The project documentation should indicate if this is necessary. Some people consider it better to always build from a temporary directory. So we'll see in one of the other videos that when the C compiler is built, we will build it in a separate directory. So here's an example of building using a separate directory next to the original source code, which is a common convention. So as before, the first step is tar xf file name. The tar ball will be exploded into a subdirectory. Now we are still in our sources directory. We issue the command make directory package name dash build. In the earlier example, the package name was Linux-5.10.17. So a new directory will be created. We issue a command cd to this temporary directory. And now look at the variation in the configure command. It will be dot dot slash package name slash configure and then some options. So let me explain this. Note that by the previous cd command, we are in the temporary build directory. Dot dot means go to the parent directory. So dot dot is the parent directory, which in this case is sources. And remember, the tar program created a subdirectory in the name of the package. So now dot dot slash package name slash configure means go to the parent directory sources, then look in the subdirectory package name, say linux.5.10.17 for the file configure. So that script will be run, and then as before make sudo make install. The CMake tool. Some projects use CMake as their build tool. CMake works somewhat like configure. It generates a make file whose content depends on the options passed to the CMake command and on the features of the local system. The steps required to build a CMake based package are identical to the configure/make, except the configure step is replaced by the line shown. As always, check the project's documentation for instructions on how to build. I've already talked about Python and Perl. They have a different means of installing. You just have to copy the files to the relevant directories. How do we pass options to configure? Options to configure the compilation and installation of an application are usually passed as command line parameters to the configure script or the make program. However, sometimes options are passed via environment variables instead. These can be specified by placing the definitions before the start of the command. For example, in a project called Linux from scratch, one may have a folder called LFS mounted on the mount folder. And the configure for that package may be looking for a variable called LFS. So before we run this dot slash configure, we will say LFS equals slash mount slash LFS. Basically, wherever it is expecting LFS, it will replace by slash mount slash refs. And then if we want that, we don't want to enable NLS, we'll also say enable underscore NLS equals no. Another way is to export these variables permanently and then run the dot slash configure. I'll talk about export when I discuss the video on bash. Which options are available is normally described in the archives readme or install files or on the project's website. Sometimes the available options can be seen by running dot slash configure dash dash help. This is very useful at times. Let me briefly discuss documentation. Documentation can come in many forms as manual file or info files. These are specially formatted ASCII files, or it could come in the form of HTML. Sometimes the documentation is included in the standard archive file and sometimes it is a separate download. Usually, the make install command will install the documentation if available. In more complex cases, the documentation may have to be pre-processed before it can be installed, something similar to the source code. You will gain experience about these things when you actually compile and install packages. As mentioned earlier, the workhorse for Linux systems is the C compiler. The GNU C compiler is called GCC and the C++ compiler is called G++. So the most common step performed by make or CMake is to invoke a compiler. This is the most interesting step as well as it is a step which is most likely to fail. If the compilation fails with an error message about not being able to find a header file or not being able to find a library file, then you have probably not installed all of the prerequisites. Moral: reread the README and install files. In some cases, the missing prerequisite is optional, in which case there will be a parameter that can be passed to configure or an environment variable which can be set to allow the software to be installed without the prerequisite. Generally, this is like using two dashes with enable or disable. Double check the parameters you specified, and if they seem correct, then the project documentation is the best resource for resolving such issues. Finally, compilers have a range of options that can potentially improve performance. However, you should only mess with these if you have plenty of experience. Otherwise, just leave the compiler options at their default. For beginners, this is the best advice one could give. Post installation. Many applications, when they start up, they look for information in configuration files. Often applications install default versions of the configuration files somewhere under slash user or in slash etc directory. You must inspect the output of make install command to see which configuration files have been installed. Configuration options should also be documented in the program's README or install or on their website. Okay, now that the software has been installed, I want to talk about cleaning up. The command make clean issued in the source directory, for example, will restore the directory state as it was just after the tar ball had finished its extraction process. So if something goes wrong or the program failed, no need to worry, just issue the command make clean. One final remark: when the program is compiled, a lot of junk is attached to the executable. This stuff is useful for debugging the program in case somebody is interested to tweak it or see where the inefficiency is, you want to optimize it, and so on. For most users, this is not important. So there's a utility called strip. So if you give the command strip and the executable file name, then it removes all the junk from that file. The biggest advantage of doing this is that your final program is very small and it will load faster. As I had promised, I will discuss an example of a makefile. This makefile uses one C source file, one header file, and makes use of one library. For each rule, if the target is missing or older than any of the dependencies based on the file timestamps, then the command or commands are run to recreate the target. However, each dependency is first tested to see if there is a rule that has it as a target. If so, that target is recursively evaluated, that is rebuilt, if it is missing or older than its dependencies. So let's have a look at a sample file. In this sample file, there are three targets: prog, libmylib.a, and libmylib.o. For the first target, the dependencies are the C file prog.c, the header file prog.h, and the library file libmylib.a. And the command to make this prog is gcc -o prog.c -l -lmylib. So it's basically instructing the GCC to create an object file with the same name as prog using the file prog.c and link it with mylib. Enter libmylib.a, the target. It depends on libmylib.o. So you can't build libmylib.a unless libmylib.o is built. And the command is ar-rcs libmylib.a libmylib.o. Finally, the target libmylib.o, it depends on libmylib.c as well as the header file libmylib.h, and that is made using again the compiler GCC. So in the above set of rules, a change in libmylib.c will cause libmylib.o to be rebuilt. And then lib mylib.a is regenerated, and finally prog is rebuilt. So just to recap, the form of the entries in the makefile, namely the rules, are as follows: name of the target, colon, list of dependencies, dependency 1, dependency 2, etc., and the command to execute. So as we have seen, we had three rules above. A change in libmylib.c caused libmylib.o to be rebuilt, and as a result of that, libmylib.a is regenerated, and consequently prog is rebuilt.